everybody, this is our last lesson on sequences where we're going to put all that we've learned together about these sequences. So there's a lot of new vocab, so let's talk about it. So there's two different types of patterns we've explored, arithmetic patterns and geometric patterns. Arithmetic patterns are all about repeated addition. Repeated addition to get to the next term. And that number has a special name called the common difference. It's called the common difference. That's the number you add to get to the next term. Geometric land is all about repeated multiplication. And that has a special number. That's called the common ratio. And how do I figure out a common ratio? I divide the second over the first, the third over the second. I divide two consecutive terms, and that tells me what my multiplier is. Arithmetic sequences are linear in nature, whereas geometric sequences are exponential in nature. So those are the types of patterns we've worked with. And there's two different ways I could write these patterns. I could write them explicitly, which is a formula that I could plug into, or recursively, which describes the pattern. Describes, let me learn how to spell here, describes the pattern. So arithmetic sequences and geometric sequences can be written either recursively or explicitly. It doesn't matter which way you do it, it just depends on how you want the formula to look. So arithmetic sequences are written explicitly as such. Start at the first term, you add on the common difference n minus 1 times. And I'm going to use g for geometric. The nth term of a geometric sequence is g of 1 times r to the n minus 1. So arithmetic is a1 plus dn minus 1. Geometric is a1 r to the n minus 1. So there's just two different ways to write those formulas explicitly. Recursively, there's two parts. You have to tell me where to start. So let's start at 2. And then you have to tell me, how do I get to the next term? Well, here's a sub n plus 1. What did I do to a sub n to get there? I don't know. Maybe you multiplied it by 5. Maybe you added 7. I don't know what you did. Maybe you doubled it and then added 1. I don't know what you're doing to the guy before you, but whatever you're doing to that guy tells you how to jump to the next term. Whereas these are an explicit formula you plug into. It's a function that you plug into. These recursive rules just describe the pattern. So let's do a tough question and then we'll get to some easier questions here. So write me an explicit formula for a sub n, the nth term of this recursively defined sequence. So we're starting at x plus 1. And how do I jump to the next term? Well, here's a sub n. There's the guy before him. And the pattern is times x. To get to the nth term, I go to the guy before me and multiply by x. Well, wait a minute. This means it's a geometric sequence. If I keep multiplying by x, I keep multiplying by x. So that's my common ratio. So that tells me the explicit formula is start at your first term times your common ratio to the n minus 1. That's my explicit formula here. That's my explicit formula. Start at x plus 1, and the pattern is keep multiplying by x. It is a geometric sequence. That's it. It looks crazy, but that's all you had to realize there. For what values of x does a sub n equal 0? When does the nth term, when does this sequence equal 0? Well, using a little zero product property here, x could equal -1 or x could equal 0. Either way, that's going to give me an nth term of 0. So this was a tough question. That's why I wanted to do it with you. Don't focus too much on it, but just know that it might look different than what we're used to seeing, but it just comes back to these basic ideas of what is a sequence. So I've got 4 sequences here for you. Pause the video, and for each one, tell me, is it arithmetic or geometric? What's my common difference or my common ratio? Write me the explicit rule and write me the recursive rule, which remember has two parts. Tell me where to start and what's the pattern. So pause the video. You've got 4 sequences to do this for. It should take you about 5-6 minutes, and then come back and check your work with mine. So the first one here is arithmetic. I'll go in the order that they have it written up there. I have a common difference of -4. I keep subtracting 4 is the pattern. The explicit rule is you start at -6, keep subtracting 4, n minus 1 times. The recursive rule looks like this. Start at -6, and to get to the next term, I take the nth term and subtract 4. Those two guys together make up my recursive rule. The next sequence is geometric. Why is it geometric? Because I'm dividing by 2. But you can't think about dividing by 2. You have to think about it as multiplying by a half. So my common ratio here is 1/2. Explicitly, start at 36, keep multiplying by a half to the n minus 1. Recursively, start at 36. To get to the next term, you take half of the nth term, half of the guy before you. Those two guys together make up the recursive rule. Slide in. I used green already? I didn't. This also appears to be geometric with a common ratio of -3. I keep multiplying by -3 there to get the next term. The explicit rule is 4 times -3 to the n minus 1. Start at 4, keep multiplying by -3 to the n minus 1. The recursive rule looks something like this. Start at 4. To get to the next term, take the nth term and multiply it by -3. Maybe you put that -3 out front. It looks a little bit cleaner. That's my recursive rule. And finally, we end with an arithmetic sequence here with a common difference of 11. I keep adding 11 to get to the next term. So my explicit formula is 13 plus 11 to the times n minus 1, not to the times n minus 1. And my recursive rule is start at 13, and to get to the nth plus 1 term, you take the nth term and add 11. Those two guys together make up the recursive rule. So this was practice of putting all this vocab and new formulas that we learned in the past few videos together here. So hopefully you did well on those. I went fast because you were supposed to pause the video and try them on your own. We've got 1 page left and we'll call it a lesson. So if the 6th term in a sequence was 36, ready? 1, 2, 3, 4, 5, 6. That's 36, sorry. And the 8th term is 64. If the sequence is arithmetic, what's the 7th term? So it's arithmetic, so I keep adding a common difference. So 36 plus 2 common differences brings me to 64. Well, I can solve that. Subtract the 36 and then divide by 2. Gives me a common difference of 14. So the 7th term there would be 50. So again, drawing these pictures are important when we work with sequences, because I understand that each time I'm adding a common difference because I said I was arithmetic. But let's change it up now. What if I was geometric? 1, 2, 3, 4, 5, 6, 7, 8. What if this was a geometric sequence? Well, that's times r each time. That's times r each time. 36 r times r, say like a pirate, r squared is 64. So now in this case, I have a common ratio I need to find. R squared equals 64 over 36. And then I'm taking the square root there. So to get r by itself, I had to use a little inverse operations there. And I get, wait a minute, 4/3 plus or minus. Why plus or minus? Because remember back in 9th grade, if you take the square root like that when you solve a quadratic equation, you have to include the plus or minus. So my common ratio in this case could be positive or negative. I don't know which one it is. So this could be 48 as the seventh term, or times negative 4/3 would be negative 48. So those are my two options. That common ratio of positive 4/3 or negative 4/3 will get me the jump that I need from 36 to 64. So that's a tough one. Notice that it depends whether it's arithmetic or geometric how I jump to the next term. Kristen wants to increase her running endurance. She can increase it by 10 miles a week. So if I increase something by 10 miles a week, what's my multiplier? 1.10. Remember, it's 1 plus the decimal if I want to increase by a percentage. If I want to decrease by a percentage, it's 1 minus the decimal. Kristen can run 8 miles in the first week. So her first week, she can run 8 miles, which means in the next week, I go to the week before me and multiply by 1.01. That's the recursive rule. And the explicitly defined rule is start at 8. We keep multiplying by 1.10 to the n minus 1. That's my explicit formula. That formula I can plug into. I can use that formula. Whereas this recursive rule is just a formula describing the pattern. So notice the difference there between those two formulas. The first row in a stadium has 300 seats, and each row has 14 more after it. So my common difference here, this is an arithmetic sequence, I keep adding 14. So my recursive rule is the first row has 300. The nth plus 1 row, you take the nth row and you add 14 to it. So that's my recursive rule. Whereas my explicit formula is start at 300, we keep adding 14, n minus 1 times. So that's my explicit rule versus my recursive rule. They mean the same thing. They generate the same sequence. They're just written very differently. So try these practice problems here, and that's it for our review of sequences. We're moving on to series in the next few lessons. See you soon.